this is part 2 of converting the DJI O3 Air unit into the O3 Lite or the O3 Ultra. Now I have a dedicated video walking you through the process. This one though is about the thermals, and I'm going to jump in and take a look at the effect of removing all of the external housing, removing the covers, and show you exactly what components get hot on the O3 Air unit, and then I'll come back at the end and talk a bit more about the effect, my testing around trying to burn this Air unit out, because I have literally left this on the bench for over an hour without any cooling to try and see what happens, and also talk a bit around the kind of times you might get with regards to it overheating in both low power mode and with low power mode off. Now, if you don't know what the O3 Lite or the O3 Ultra is, it's a modification that you can do to the DJI O3 Air unit that helps reduce weight. DJI do not sell it like this from the factory, but you can buy this kit from FlyWoo that allows you to reduce the overall size and weight of the Air unit, and you can take it down from around 34 grams to as little as 18 grams. The O3 Air unit Lite is simply the Air unit without the outside housing, and the Ultra is the same Air unit, but you remove the heat shielding SD card slot, and whilst this does restrict you in some of the features, i.e. you no longer have the SD card recording, you do have the absolutely lightest possible version of it. Now when doing this, you're removing the external housing, and this is also removing the heatsink that is part of the Air unit, helping to keep it cool. So what we're going to do next is take a look at the effect of this under the thermal camera. To show you this, we've reassembled the Air unit in its bare bones state. We've got the camera connected, we've got some antennas, we've got a power cable and the cable between the boards. And what we're going to do is get it under the thermal camera and take a look at exactly what components on this board are the ones that create all of that heat. Now the thermal camera I'm going to be using to do this today is my Enquiries P2 Pro. This is a fixed focus thermal camera. It has the standard lens, but you can also get this macro lens that allows you to get in really nice and close to the PCB, and you'll actually see this in the video. We use it without it first of all, and then with it again in a minute. Now this thermal camera is the USB-C one, and this is designed to actually be used with smartphones. However, today I'm going to be using this on my PC, and I'm going to be using it with a third-party piece of software called IRCam. Now I am going to make a dedicated video on this software in the near future. It is a purchasable piece of software. It is not free, but it has some truly amazing features designed to allow you to get the very best from your thermal camera. This software isn't made by Enquiries itself, it's made by a third-party developer, and he's put together this software to allow you to be able to do some frankly amazing things with your thermal camera on your desktop, and it really is designed for very professional use, but it allows you to just do so much more than you would be able to do with the Enquiries app. And as I've said, I will make a dedicated video on that in the near future, so if you're interested in seeing that, please do make sure you are subscribed, and I'll also put a link to his software in the description too. Okay, so we're ready to power this up. We have the goggles turned on, so when this powers up, it will connect straight away. I don't have the macro lens on this thermal camera at the moment. I'm simply using the normal lens. It'll be interesting to see how much detail we do get with this, but if we do want more, we can move over to the macro lens and get in closely. Now, just for point of reference, this side you're seeing here, this is the P1 chip, and then what we've got in the middle is the Eagle 3T down there. There's some RF stuff down that side, and then we've just got power regulation on the back of the board. So if we power up, we'll just wait to see what happens. We can now see that we're getting some temperature on the P1 chipset showing there. If I then just wait a second, lift up inside, we've just heard it connect. We can see the Eagle chipset is there. Oh, there's a lot of heat on that board there. The P1 is definitely the chipset that is getting the hottest so far, with the Eagle chipset under there actually not getting that hot. And if we go to the back of the board, we're definitely getting heat, but really the majority of it is down there, which is hardly surprising because that's our RF power amplifiers. And then our P1 chipset there in the middle. What I'm going to just do is flip it this way so we can have a better look at this side of the board inside. Wow, that is getting incredibly hot. I can actually smell it now. There, we can see the areas that are getting really hot. Okay, so the macro lens is fitted. What we're going to do is power it back up again. We'll wait for it to connect. We'll hear that. There you can now start to see that P1 chipset again getting very, very hot. If we actually want to, we can put a temperature tag on that. So let's turn that on. We can see there that we're getting to 77, 78 degrees. That is getting incredibly hot. If we flip the board over, yeah, the Eagle really isn't getting that hot at all. There's not that much heat there, considering it's a powerful chipset. It's the P1. And then if we flip this over very carefully down there, oh wow, we can see that component there is 89 degrees. That is really getting hot. We'll have a look at what that is in a minute. Our RF power amplifiers are there. You can see them just in the image there. Oh, that transceiver gets hot, and that down there. Wow. That is where all the heat is in the board, is down that side there. 99 degrees. It's that hot. I can't actually touch it at the moment. It is incredible. Wow. I'm going to turn it back off a moment. Okay, so I've cooled the air unit back down, and I've had a chance to have a look at the other side of that board of what components were there. And actually, what's getting hot is the back side of the board to the P1 chipset. There's no real IC or other components there, so that heat we're seeing on the back side of this board is from the bottom of the P1 chipset with the large heat pad is underneath. Now we're going to do some more tests again, but what we're going to do now is turn off low power mode and start recording just so we have an idea of what is generating heat. Now I'm going to do this without a fan first, but I honestly don't know how long we're going to have. So what I'm going to do is turn on, wait for it to connect on the goggles, and then get in and disable low power mode. We can see the P1 is starting to heat up there straight away. Just waiting for it to connect. It seems a little slower to connect actually, which is interesting. Right, there we go. I'm into the settings, so we're going to go into control, turn off low power mode. There we go. So now low power mode is turned off. What I want to see is if there's an effect on the power amplifiers as a result of turning off that low power mode. They're the two chips you can see down there, right at the bottom. Let me just flip it over again this way so we can see it. Let me just flip that up. There we go. There is our two power amplifiers. No, they're not getting that hot at all. That there, that temperature you can see there, that 90 degrees, that's the back side of the P1 chipset on the other side of the board. So even with low power mode turned off, low power mode turned off, we are not driving that much heat through the amplifiers. It's all that P1 chipset. It really is that IC. It's incredible. Okay, now I've got it turned on and I've got a fan blowing over it at the moment, and I've had it on for about a minute, and what the fan is doing is just keeping the temps somewhat under control. And what this is allowing me to do is just see exactly which components it is that is getting very hot. So it's definitely the P1 chipset. That is by far the #1 generator of heat. If we look underneath, the Eagle definitely gets hot as well, but it takes a bit longer to get there. It doesn't get as hot as quickly as the P1 chipset on top. And then If I flip the board over on the bottom side, there is a regulator there that does get very hot too. Obviously that's providing power, so that gets hot. And then if we keep rotating round, because that way then we're going to get to the other side, we can see our RF transceiver down there. Our power amplifiers there, they're getting hot, but not crazy hot. And then it's the back side of that board over there. But overall, you can see exactly which components are the ones that are driving the heat and where the airflow is going to need to be, more than anything, around this P1 chipset here. Taking a look at some still images of the O3 air unit just to show you exactly what is creating all of the heat. Now, the number one thing is this, the DJI P1 chipset. This is the same chipset we saw in the original FPV system, and this is by far getting the hottest, and it is the first chipset to turn on as well when you power it up. You will see that we do have some other components around it, but it really is the P1 itself that is creating most of the heat. If we flip around to the other side of the board, you will have noticed we've seen a lot of heat in this area here. That is actually the bottom pad area of the P1. Under this chipset is a big copper pad, and that was what was showing the heat on this side of the board. We do have our IE1000 transceiver. That was getting very hot as well. And then below this here, this is our power amplifiers. And whilst they were certainly not cold, they weren't remotely getting as hot as the P1 that you can see here. What's interesting when we talk about those power amplifiers on this side here, on the other side of the board, you have this little metal piece there that again is designed to help radiate the heat away from the PAs, and that's actually going to act as a little bit of a heat sink, again helping to keep these cool even in the scenario that we've got it here without the shielding on board. Moving over to the second PCB, or the IO one as I like to call it, we've got our E3T here. This is the main Eagle chipset. Again, it gets hot, but it certainly isn't as hot as the P1. This again is going to be sandwiched in the middle between the boards, and there really isn't a lot you can do other than making sure that there is airflow able to get through the gaps on the side of the mounting kit. Finally, on the other side of that board, we have our power setup. So this is predominantly where all the regulators are. Again, that little chip down there was getting very, very hot, but this isn't really anything you need to be concerned about. More than anything, it is this side of the board that you want to make sure is getting the airflow. This should definitely be at the top, and you want to make sure when you're sandwiching the boards together and putting them in your frame that there is airflow able to move between the boards. That way, this side is going to get some cooling as well. Those components there are not going to get too hot and potentially unsolder themselves, and you're going to get airflow over the transceiver and the power amplifiers. However, as I mentioned, I'm not really concerned about the power amps because we do have this thermal mass over here to help keep them cool. Next thing I wanted to do was get a baseline on how long it would take for the O3 air unit to overheat in both low power mode and in normal full output now it's naked. FlyWoo do actually have some numbers on this that they show on their website. However, I do want to do the test for myself, so let's take a look at it in both those scenarios. So the first test here is the DJI O3 air unit in low power mode. The second this video started was me powering up the O3 air unit itself. You'll see in the bottom right corner I actually have the camera view being recorded as well, and you'll see the point of how long it takes for the O3 air unit to connect and then for it to actually overheat. Now, I'm not going to let this completely run real time. I'll speed it up and I will show you then the outcome of the results. And as you can see, it took roughly 2 minutes and 45 seconds from completely cold power on to overheat. This surprised me actually. I was expecting it to be a lot quicker than this, and it's certainly not as quick as the numbers FlyWoo was showing on their website. This was in the workshop from completely cold and at roughly 20 degrees ambient temperature. It's also interesting that it went on for nearly another minute before actually shutting itself down due to overheating. So again, you can clearly see, even though we have removed the heatsink, we have removed a lot of that metalwork, the air unit is able to somewhat regulate its temperature in low power mode. is if we take a look at this now with low power mode turned off, it certainly doesn't last as long. However, it still is over a minute. And again, I'm pleasantly surprised by this outcome. However, it is worth mentioning again that this is from ambient room temperature. I left it completely cool down for these tests. However, in the real world, when we're out flying, when you're doing things like swapping packs, you're going to get a lot less time and you are going to have to be careful. Now, the last question I wanted to answer is, how long would the O3 Air Unit Lite or Ultra last if it was just left on? Now, this test I did basically in low power mode to simulate having a crash or a landing where you couldn't get to the aircraft, and I simply left it on the bench. Now, in this case, what you find is the air unit will give video to the point of it overheating like I showed earlier, and then it will start to shut itself down, and the air unit then will cool itself over time. What it will not do, though, in my tests is reconnect once it has entered this low power mode, unless you completely reboot it, which means if you were to crash somewhere, you are going to need to be able to reboot it to be able to get that video image to reappear. We also did some checks on what would happen if you actually cooled the air unit manually. So I placed a fan over it once it had powered down to simulate it getting cooler. But again, it still did not recover. The only way that the image would reconnect to the goggles was if you actually powered it down and reconnected. Finally, I just did a quick couple of thermal tests on the camera to check what was going on there. And really, I've seen nothing untoward. So in low power mode, you're talking about 2 minutes 45 from completely cold to giving you the overheat warning, and about another 50 seconds beyond that before it shuts down. However, with low power mode turned off, you're talking about 1 minute 20 and then literally only about 8 seconds more before it actually shuts down. Now, this is going to vary massively depending on your ambient temperatures, how enclosed the air unit is, and as I did touch on in that part of the video, it is going to potentially be an issue with regards to swapping packs, especially when you're landing or in a crash. You're going to need to take great care on how fast you're able to actually get to your aircraft if you're landing and swapping batteries, because you could end up in a position of finding the aircraft is overheated before you've even been able to take off. And this is something I'm going to be testing a lot more in the third video I'm going to be making on this when I actually get this aircraft out for its tests. Now, there is some interesting things I wanted to test with regards to this overheating as well, and that is there any potential for damage on the O3 air unit if it is left in a situation where it can't get cooled? Now, I left mine pretty much to burn itself up on the bench. I left it for over an hour at one point, and the basics are the O3 air unit will get very, very hot. It will get to the stage of overheating, and then it will shut itself down, and then it will just sit there at that point at a pretty high temperature, 60 degrees roughly, but what it won't do is fry itself. There should be no concerns with regards to running this and damaging the air unit if it was in a situation where it wasn't getting airflow. It should pretty much regulate itself, although it is worth understanding that those chips, that P1 as I've shown on the top, does get around 90 degrees, and it's less about that I have a concern and more around the components on the other side of the board, resistors, capacitors being subject to that high level of heat over long periods of time. I don't expect it to be a problem in flight as long as you've got good airflow. However, if airflow is an issue, you could run into problems, and we have even seen on things in the past where they get that hot it can even desolder components from the board. We've never seen that on O3, but it isn't beyond the realms of possibility. So when you're designing your aircraft with this O3 Lite or O3 Ultra air unit in, you're going to need to make sure that officially it is going to get some decent airflow when it is in flight. So that is it for the thermal deep dive on the O3 Air Unit Lite, or the O3 Ultra as this one is. Now, I am going to be doing a third video, which is my test flight on this all with the Pavo Pico. I wasn't able to squeeze this into the first two videos for varying reasons, so if you're interested in seeing that, please do make sure you are subscribed to the channel. I really hope the info that I've given you in this video is helpful, and if it is, please do give it a like. Please do let me know what you think in the comment section, and if you're interested in seeing the full process of turning your O3 into this, as I've said, there will be a link to that original video in the description. Finally, I just want to say, if you'd like to support us to allow us to keep making content like this in the future, please do consider checking out the link to my Patreon. I want to say a massive thank you to all of my patrons for supporting the channel. We would not be able to keep making content on this channel without your support. And if you'd like to support us to allow us to keep making content like this in the future, there's a link there. Please check it out. Anyway, that's it from me on this one. Stay safe. I'll speak to you soon.